The ability to easily scale is one of the main advantages of cloud-based computing. It allows you to deal with an increase or decrease in traffic easily. It comes in different flavors: vertical scaling and horizontal scaling. Vertical scaling, also known as scaling up or down, means changing the resources available to your physical or virtual machines. In case of scaling up, that means more or better CPUs, more memory, a faster hard drive, and other options. The same machine can thus potentially handle more traffic. Scaling down is a decrease of all of that. Horizontal scaling, also known as scaling out or in, means changing the amount of physical or virtual machines. If you add more, you're scaling out. Incoming traffic can thus be distributed across more machines, allowing you to potentially handle more traffic. If you see less traffic coming in, it's time to scale in by removing some of those machines. I specifically said potentially in both cases. Of course, generally speaking, both vertical and horizontal scaling will have positive effects on the amount of traffic that can be handled. But part of it also has to do with how your code is written. For example, if you write async code in .NET correctly, you increase the vertical scalability of your system, as threads are potentially freed up earlier, which releases resources on the same machine faster so they can handle other work. If you write stateless code, you increase the horizontal scalability of your system, as it doesn't matter anymore which server the request ends up at. So, your code base still matters. Alright, with that you know what scaling is. In Azure, the ability to scale is tied to your app service plan. Depending on the tier, none, one, or more scaling options are available. I've opened the page here over on Microsoft's documentation. You can find that via the URL on screen. And if I scroll down here, I get a nice table with an overview of what is possible. What you can see here is that the minimum app service plan you need for any sort of scaling option is basic. So the free and shared tiers don't offer scaling options. Basic gives you manual scaling options. That's pretty self-explanatory. You have to manually, over on the Azure portal or via the CLI, scale. Horizontal and vertical scaling are both supported with the manual option. The second option is auto scale. For this you need the standard tier or better. With auto scale you can apply horizontal scaling depending on a set of rules. For example, a rule could be scale out with 3 instances on Monday morning and scale in again on Friday evening. Or scale out when CPU usage is above 70%. Autoscale does not support vertical scaling, only horizontal scaling. The final option is automatic scaling. You need a premium tier for that, and it's one step beyond autoscale. With automatic scaling, you don't have to define rules on when to scale anymore. Instead, the scaling decisions are automatically handled by Azure. You can of course still define some settings, like the maximum amount of instances. This too only supports horizontal scaling. Let's have a look at that over on the Azure portal. This is our app service. Let me search for scale, and in the menu here we see 2 options, scale up and scale out. Let's start with the first one, scale up. Scaling up or scaling down, that is vertical scaling. And you can only do that manually. As you can see, I can select another tier here if I want, and this will directly affect my app service plan. I can choose one with more or less CPUs, memory, storage, and so on. To be able to show you the automatic scaling options, I'm going to temporarily switch to Premium v3. This will start costing quite a bit of money, so be careful with what you do here. I'm only going to quickly enable this for the demo. Let's click Select. And let's click Upgrade. And there we go. This is manual scaling. Now let's go to automatic scaling. For that, I'm going to switch to the Scale Out option. This looks a bit different. I can still manually scale out simply by increasing the instance count here, but I can also choose automatic and rules-based scaling. Let's go for rules-based first. That's the auto scale option. And let's click configure. And let me click custom auto scale here. And if I scroll down here, I can choose to scale based on a metric, for example. By default, one rule is already included. It will increase the scale out count by 1 if the CPU percentage is above 70%. If I click that, I can go ahead and configure this rule. I could, for example, say that we want this to be at least 20 minutes above 70% before starting to scale out, instead of the 10 minutes that were set before. Let's click update here, and there we go. Let me choose to add another rule here. And as you can see, there's quite a few things we can look for and use as a metric. You can work on data in or data out. You can work on the CPU percentage. You can work on the memory percentage, and so on. We're good with what we've got. You could add additional rules if needed, but we're good to go. We can also define the instance limits here, so the amount of virtual machines that will be used. Minimum 1, maximum 5 sounds good. So let's click save on top here. And with that, we have defined our custom auto scale setting. In case you prefer using the CLI for adding these rules, AZ monitor auto scale is the command you're looking for. Alright, let me go back to the previous blade and have a look at the other option we had. Automatic scaling. You can define the maximum burst. That's the number of instances that can be used for scaling. And you can also define the always ready instances. An always ready instance is one that has previously been warmed up, which avoids that typical first hit startup time you typically have with web apps. Potentially, you can also enforce a limit on the amount of instances that can be used to scale out. Let's set that to 2 and let's save this. And there we go. Automatic scaling has been set up. In case you prefer to use the CLI for enabling automatic scaling, you can do that via the App Service Plan Update command. The option you're looking for is Elastic Scale, and potentially the maximum amount of elastic instances. Via the AZ Web Update command, you can then configure the minimum elastic instance count and the amount of pre-warmed instances. Alright. I am going to set all of this back to manual to avoid unnecessary costs. And let's save this. And I'm also going to go to my app service plan and change this back to basic. And with that, it's time for the section summary. This section was all about Azure App Services. We learned how to create, manage, and deploy an API to an app service. Azure App Service is a platform as a service for hosting web apps, APIs, and other web-based backends. It supports multiple languages, including ASP.NET Core, Java, PHP, Python, and Node.js on both Windows and Linux. You can create and deploy an app service via the Azure Portal, the Azure CLI, or directly from Visual Studio. The process involves selecting a subscription, resource group, runtime stack, operating system, and pricing plan. These pricing plans, named App Service Plans, define the compute resources for your app, including the operating system, region, virtual machine instances, and pricing tier. Pricing tiers range from free to premium, each offering different features and capabilities. Scaling is tied to this app service plan. For an app service, vertical and horizontal scaling are supported. Manual scaling is available in the basic tier, while auto scale and automatic scaling are available in higher tiers. Vertical scaling, also known as scaling up or down, means changing the resources available to your physical or virtual machines. In case of scaling up, that typically means more or better CPUs, more memory, a faster hard drive, and other things. The same machine can thus potentially handle more traffic. Scaling down is a decrease of all of that. Horizontal scaling, also known as scaling out or in, means changing the amount of physical or virtual machines. If you add more, you're scaling out. Incoming traffic can thus be distributed across more machines, allowing you to potentially handle more traffic. If you see less traffic coming in, it's time to scale in by removing some of those machines. The minimum app service plan you need for any scaling option is basic, so the free and shared tiers don't offer scaling options. Basic gives you manual scaling options. If you have the standard tier or better, you can enable auto scale. That allows you to apply horizontal scaling depending on a set of rules you define. The final option is automatic scaling. You need a premium tier for that, and it's one step beyond auto scale. With automatic scaling, you don't have to define rules on when to scale anymore. Instead, the scaling decisions are automatically handled by Azure. Most applications need to deal with application settings. These can be managed directly in Azure, overriding settings in the app's configuration files. Settings can be added or modified via the Azure portal or the Azure CLI. And with that, it's time for the next section, in which you will learn how to work with Azure Storage.